Hello and welcome to this session on Introduction to Data Science. My name is Roshan and we are going to have a look at what this buzz is all about. In this session, we will talk about what is data science, what are the needs for this whole new buzzword field of technology, what exactly those so-called data scientists do with what tools and technologies, how do they do it, and why is this new field of data taking over the market like a wildfire. I will also briefly touch upon my personal experiences regarding this data domain, and then we will talk about the increasing demand of the data scientists across the globe. Alright, so let's get started now. I'm sure you must be wondering what is data science and why do we need this? But before that, let's briefly discuss about the core around which the whole data science revolves, that is the data. I will not go around the discussion and give you the theory about how important data is in today's world, but let me give you one example, a very recent example. A recent case of an American company called Surgisphere located in Illinois, United States. You can look it up on the internet. The company claimed that they have gathered the data of corona-infected patients by linking their software used by 671 hospitals across the globe with their electronic health record system. The data was about the combination of medicines used to treat the corona-infected patients and their effects on the patients. Now, based on this data, the two most reputed science journals, namely The Lancet and the New England Journal of Medicine, published a report which concluded that the drug hydroxychloroquine is not effective in treating COVID-19 infections. And hence, based on these reports, most of the countries across the globe, they have changed their treatment policies, and the World Health Organization also announced to stop the trial of hydroxychloroquine drug. However, this policy by WHO, it has raised a lot of cautious distrust, and the company Surgisphere is now under scrutiny and investigation with the likely possibility of being a fraud. But the case is still under investigation. Meanwhile, WHO has also started again the trial of hydroxychloroquine drugs. Now you must be wondering, why did I mention this case? I mentioned this case because I want you to understand how important data is, especially in today's time, in COVID-19 situation, when the whole world is making its treatment and research policies based on data. Data is shaping the path of research and innovations today more than ever before, and it is going to grow bigger and larger. And to make sense out of those data, we need people with skills who can actually carry out the researches based on data and convey the results in a manner that is understood by the world. We started this session on a serious note, but let me give you a few more examples. We all know about Netflix, YouTube, Amazon Prime, and many other such similar streaming platforms for consumers, right? You buy a subscription, log into the portal, search for your favorite movies or web series, and start watching. Now, there's a plethora of content available on the streaming platforms, and if these are not managed efficiently, then the consumer will grow tiresome and opt out of the subscription. To keep the consumers engaged and interested, these streaming platforms, they try and understand the behavior and nature of the consumer. They will try to figure out what type of movies you like, any specific actor or director you might be interested in, and all those kinds of analytics. They do that with the help of various machine learning algorithms. In this way, they try to give you a more personalized experience, and data science helps them with that. And we all know it's working in a very good way for these streaming companies, don't we? Because the numbers of subscriptions are growing crazy. But that is just one sphere of our day-to-day life where data science plays an important role. There are many more. Let's take an example of the transport system. Let me tell you something more about that. A more local example would be better probably. So you all know about Mahindra Automobiles, right? The indigenous company. They have an industry section called as Mahindra Electric. Now the Mahindra Electric, it sells electric vehicles, and all those electric vehicles are connected to a platform called NEMO, which stands for Next Generation Mobility. These electric vehicles, they generate a lot of data which is being sent to NeMo for analysis. The data scientists at Mahindra Electric, they then analyze this data and help generate real-time reports and notifications. For example, let's say if you want to move from destination A to destination B, and with the help of this analysis, let's say if you move out of your destination route or locality, then you get an instant notification. If you are a transport company owner, then you get the real-time updates of all your vehicles, which helps in efficient fleet management. The same goes for other automobile companies as well. You know about Tesla, right? It also uses machine learning for fleet management and driving your car in an autopilot mode. The same goes for Mercedes, BMW, and all other big players in the market. You see, data science and machine learning is already an inseparable part of our life without us realizing about it. One such inseparable part of our day-to-day lives are banks. Yes, the banks in which you hold your accounts, saving accounts or current accounts. For example, the HDFC Bank, ICICI Bank, State Bank of India, Citibank. They use this machine learning for keeping their losses under control and providing better security and fraud protection to the customers. A lot of banks also use behavioral analytics to check if the authorized personnel is logging into the banking app or the web portal. The algorithms which runs in the background study your behavior for some time. Your behaviors like the way you type your username, the way you type your password, how do you move your mouse cursor, and a lot of different other things as well. Once the algorithms are trained enough, they start telling the bank if the correct person is logging into the app or the web portal. Now, based on that, you can get less or more authentication options during logging in. The same goes with your transactions as well. The banks use various machine learning algorithms to minimize the occurrence of fraudulent transactions. There are many more other areas as well where the data science is being used a lot, like the way Google Maps suggests you the best possible routes, or like the way Make My Trip suggests you the best possible flight options, the way Google Search suggests your search results based on your search history as well as the location proximity. The list goes endless. But to summarize, in the business context, data science is mainly used for better decision making, because there are always tricky decisions to be made. Which is the right decision? Which way to go? We discussed about the case of Surgisphere during the start of this session and how it affected the decision of World Health Organization as well as many other countries. So, data science is used a lot for better decision making. We also have discussed the case of streaming platforms, the Netflix, Amazon, YouTube. They suggest contents to customers based on their interest. It can also be used to predict delays in transport system, the wear and tear of the vehicle components. Basically, what to suggest course of action or preference or what happens next, that is the prescriptive and predictive analysis. We also discussed about the banks and the way they tell if the right person is trying to log into the app or the web portal. Basically, the algorithms try to discover patterns in your behavior, understand it, and takes decision accordingly. Well, if you want to know more about the behavior analytics and pattern discovery through machine learning, I suggest you to look up for a product called as BehavioSec and learn more about it. I understand you must have noticed me using the term data science, machine learning, and few other jargons interchangeably. Do not get confused. Let me tell you what data science is and what all skills a person needs to possess to be a working data scientist. By definition, data science is an interdisciplinary field that aims to provide intelligent business insights by studying, understanding, and learning from both structured as well as unstructured data. Quite a mouthful, but let me ease it down for you. Basically, a data scientist is a person who is better at statistics than any software engineer and better at software engineering than any other statistician or a mathematician. What I wish to tell you is, if you are a techie having a computer's background, be it your studies or your current job, you already do possess some of the skills needed to be a data scientist. For those who are starting from a totally different background, worry not. It is not something that cannot be learned. You see, the first skill set you need is the knowledge of the subject software engineering. This includes the knowledge of software development, but ultimately it boils down to the knowledge of programming language. We will shortly see what programming languages are suggested and preferred for data science. Then you also need to know a bit of statistics. Mind you, statistics is a very vast field of study. You need not to indulge in anything else which might not be related to the subject. You do not want to end up spending all your time trying to understand mathematics and not programming at all. You just need to understand few relevant topics of statistics. That's it. And then the combination of software engineering and statistics is machine learning. This is where you need to have the knowledge of algorithms. Although you do not have to derive every other algorithm or to absolutely know about every single algorithm in the world, but you do need to understand few important algorithms, how they work, which is suited for what kind of data, and the details like that. Then comes the subject of domain knowledge. This is very crucial if you want to be an expert, a senior data scientist. For fresh graduates or people who would like to start at not so senior position in the field of data science, this can be an exemption. But it does give you a competitive edge if you have a good knowledge and understanding of business. And the selective combination of the skills from these subjects makes data science. As a data scientist, you must understand the data you have at your disposal, which algorithm will work for your data, and how to improve the same. Model an algorithm using the programming language by selecting the features or the data that really matters as per your business knowledge. And then finally convey the results to the stakeholders in an effective manner of graphs or reports. This is what makes a good data scientist. Now that we know what are the subject skills one needs to have to be a good data scientist, let's drill down on that and be more specific on what technologies or tools one needs to learn. Here are some of the programming languages that are suggested: Python, R, SAS, MATLAB. You need not to learn them all. One or two will suffice. As more and more of the developer community is getting into data science, Python has become the programming language of choice for data science because of being open source, good libraries, as well as its vast community support. The R programming language comes next. SAS has been the most powerful and popular for data analysis in the past few years, but because of the expensive license, it has loosened its grip over the market. Although quite a few big enterprises still use SAS. The IDEs, or the integrated development environments, that you must know to write code are Jupyter Notebook for Python and R, RStudio, which is used specifically for R. You could use a RAD tool like RapidMiner as well. The suggested IDEs if you are using Python is Jupyter Notebook, and if you are using R, then it's suggested to use RStudio. From the extract, transform and load perspective, commonly known as ETL, you should have the knowledge of open source technologies like Structured Query Language or SQL, Apache Hadoop, and Apache Spark. If you have the knowledge of proprietary tools such as Informatica, Talend, or AWS Redshift, then that is an added advantage, as quite a lot of data warehouse solutions still use those licensed tools. When I mentioned that you need to learn programming language or languages, there's a catch here. You necessarily need not to learn all the nitty-gritty of programming language, although if you can do that, it's wonderful. But essentially, you only need to understand the basic syntax of the programming languages and some specific libraries or packages. There are some specific libraries or packages in programming languages which are used for data science. For example, there are libraries in Python for data visualizations like Matplotlib or Seaborn, and for data processing like Pandas or NumPy. One more thing that you should know about the data visualizations is that there are multiple data visualizations and reporting tools available, which are also called as business intelligence tools or BI tools. For example, Microsoft Power BI is one, SAP Business Object is another one, then there is Tableau, QlikView, QlikSense, Kibana, and many more. The difference between the visualization libraries in programming languages and these BI tools is that these BI tools are much more extensive, much more powerful and provides much more flexibility and ease of operations when it comes to the data visualization and reporting. And the last part of technology and tools that you need to learn are some statistical and machine learning libraries. Python has scikit-learn, Skippy or SciPy, depends how you pronounce it, NumPy, and few other libraries for machine learning and statistical implementation. R has its own machine learning and statistical packages. Spark has mlib. Apart from these, the cloud providers like AWS and Azure, they have also developed their own machine learning solutions. Azure provides ML Studio for machine learning implementation, while AWS provides SageMaker. So remember this picture. You will need to have these skills to start working as a data scientist. Once again, I repeat, you absolutely need not to learn all those skills, but only the most preferred ones in every skill set. So now you have an idea of what skills are required for one to master to start working on this field. Let's see what exactly does a data scientist do at his or her work. Well, by the definition, a data scientist is given a business problem that needs to be solved. The data scientists then talk to the business stakeholders to understand the problem thoroughly by asking questions, the right questions, and discuss more and more about the problem. Once the data scientist understands the problem to its core, he starts looking for data to solve the problem. With some help, once he gets the data, he makes sure that the data is in a proper format and is clean and ready for analysis. He then puts the data into analysis, which could be done by a machine learning algorithm or a statistical model, and get the meaningful insights or results, which is then communicated to the stakeholders or the business. That is basically what a data scientist do at his work. However, that's a textbook definition. Let me share my personal experience with you. What problems do we solve at work? How do we do it? What challenges do we face while doing the analysis, and how do we evaluate and communicate the results to the stakeholders? Well, you see, I work with a bank with a team of fraud security experts. The problem we are trying to solve at the bank is to be in control of this constant, ever-going battle between the fraudster and the bank. We want to minimize and potentially get rid of the losses that our customers as well as the bank bears due to the frauds happening in the day-to-day life. So I sit with a team of fraud security experts and understand the problem. I try to understand where the bank is losing its money, what type of frauds are happening the most, and then targeting those type of frauds at first. Once I understand the problem, I go out looking for the data. Now this is easier said than done, because for us, initially it took months to build a data pipeline backbone, which can get the data flowing from customers to our backend data lakes. We used quite a few industry standard solutions like IBM, Apache, Azure to build our data pipeline solution. Once I started receiving the data, I have to make sure that it is usable and not just any other garbage data. Because once the data starts flowing from the customer, there are a lot of hops in between, and that data might get corrupted, or sometimes the data in itself is not just correct. Cleaning hundreds of gigabytes of data every day needs quite some skills and a very reliable and performant environment. Sometimes there are teams which set up those environments and maintain those environments for you. But it could also be the case that you have to set it up on your own. Well, that is not that difficult in this era of cloud computing, but for me, my team takes care of the environment, making sure it is up and running and available for me to do the job. Once the data is cleaned, I train various machine learning models by selecting the required data only. Look, the catch here is the data we receive every day is huge, and the data I use for analysis is usually the data of few months, sometimes data of few years, and we might not need all the data for getting effective results. And that is where your domain expertise comes into picture. Plus, there are government regulatories like the GDPR compliance, which tells us not to process or analyze any PII data. What is PII? PII stands for personally identifiable information, like your phone number, your name. Basically anything that identifies you explicitly is not permitted for us to process. So we have to be cautious of that as well. Once I train and test the models, it generates certain outputs. I have to validate if the output or the results are up to the mark. If not, I have to repeat the process until I get the satisfactory results. And then these results are shared with the stakeholders in the sprint review meetings. Yes, we work in Scrum Agile fashion. Sometimes I use dashboards made by those BI tools like Microsoft Power BI or Kibana, but other times I just convey the results using slides as well. It totally depends on what and how you want to convey the results. Once the results are accepted by the stakeholders, we put those models into production so that they start working in real world. And this is how a data scientist works. If this sounds all complicated, then let me break it down for you. Let's generalize the data science project lifecycle. The very first step is when the stakeholders come to you looking for a solution to a problem. You do the concept study. You ask questions, the right questions, and understand the problem to its core. Then you go all out to collect and prepare data for analysis. Some people also call it data munging or data wrangling. There are lots of jargons to it, but it is basically preparing your data in a particular format for analysis. Once you have the data prepared, you do the analysis on how to build a model, what statistical model or machine learning model to choose, what all data to choose, etc., etc. Then comes the actual model building part. Note that this is probably the easiest part in the whole data science work. There are lots of libraries out there available to simply import and use the models. The actual work goes into the stages before and after the modeling. Once you write the model and start testing it, you get the results. If the results are not good, you simply go back to the model planning phase and look for the ways to improve it. But if the results are satisfactory, then it's time to convey those results to the stakeholders. And if the stakeholders are happy with the results as well, then you actually go ahead and operationalize the model that you wrote. Basically, you put those models into production for those models to start working in the real world environment. And that is how a life cycle looks like. It is pretty much a standard across the industry. And now let's move on to the last part, which is one of the reasons why you're taking this session. Yes, the opportunities and future prospects of data science, which by my personal experience I can tell are very promising. Depending on one's experience within the domain and the industry, need not necessarily to be a data science experience only. You have the options to start as a junior, mid-level, or a senior data scientist. I get messages from recruiters every week on LinkedIn who are looking for data scientists, and the reason for that is simple. The demand for data scientists are huge and there are not enough people with the required skill set. And this domain is growing bigger and larger day by day, simply because of the fact that it is not limited to any particular business domain. It is growing crazy in gaming industry. They need a large number of machine learning engineers as well as data scientists there. The healthcare industry. We started this session with the discussion of the case of COVID-19 patients' data and how the World Health Organization and most of the countries define their policies based on the results of data. The finance industry, I'm working in this domain for more than 6 years now, and I can tell you that it has just started. The media and entertainment industry, the technology industries like electric vehicles, the Mahindra Group, the Tesla, Mercedes, BMW, everyone is moving towards data-driven decisions. It has become very critical to master the skill set in this age and time to be relevant. So that was your introduction to data science. I hope now you have a better idea of what data science is, what skills you need to start working as a data scientist and accelerate your growth. It has been good interacting with you. Thank you.